problems. All right. The first REST constraint which we discussed, client-server computing. Let's see what are the problems addressed by the client-server, such as using client-server constraint, servers no more know about their client, and only clients know about server. It simply means we can add or remove n number of servers at will. Same way, client-server also allows us to scope the boundary for the connections between client and server, an important attribute of any network architecture to enable security and even to monitor. Because we also did the separation of concerns, portability of clients is achieved. That is, server can evolve and handle any kind of clients that are requesting its services. Hence, broad network challenge can be now addressed. Same way, next is the stateless communication. Because of the stateless communication between client and server, more than one server can handle the workflow request. We already saw an example of that. Same way, because now our servers do not store any state information on them, or the client is passing all the required data to the server required to process the request, we can increase the resources and we can achieve the increase in performance, which is the textbook results for scalability. Because servers do not store any state information on them, servers are impervious to reboots, network outages, or even any kind of crashes on the client side. If a workflow is abrupted either because of the network outage or a client crashing, client can simply take the earlier saved state from server and can update it or can continue with its workflow. Thus, there is an absolute fault tolerant system achieved. Because state is now shared across the clients of the server, visibility to state is available with all the clients and its intermediaries, such as the caching systems. All of this helps us increasing scalability, elasticity, and resilientness of the cloud services, which makes the cloud much more reliable than ever. Next, let us have a look at the cache, how it addresses some of the REST problems and the cloud challenges. Because we can cache now at our PCs, our browsers, or our company proxies, or the internet provider proxies, latency will be largely reduced. The direct benefit of this is on your mobile phones and tablet devices, where network is not reliable and latency is huge. Because of the local caching, this latency can be largely reduced. Because response can now be cached by your browser, local proxy, or anywhere within the network, entire network is a resource for cloud services. Hence, your system can be scaled out using all the network resources which are available, not just the resources that are being used on the cloud. Hence, it saves a lot of bandwidth and efficiency of your cloud services. Thus, improve the scalability of your cloud services. Next is the uniform interfaces. Uniform interfaces were newly introduced. Earlier to this, whenever a distributed web or a distributed hypermedia system was to be developed, it has to be developed using the same implementation library. You might have seen that whenever a Java program wants to communicate with a .NET or a C++ application, we used to use COMs or DLLs. which is no more required with the help of RESTful APIs. Because now resources are identified uniquely and manipulated over hypermedia, uniform interfaces offer a standard mechanism to develop the web applications. Because the resource identity is standard, it allows the network topology to be greatly innovated, hence makes the network reliable to a large extent because we now have a standard messaging syntax. Same way with the network topology and complexity in addressing network applications. All this allows measurability and evolvability of your cloud services because having uniform interface allows us to remove and or refactor the server component with a better quality one without impacting any of the clients. Let us have a look at the next problems addressed by REST. Layered architectural constraints. Layered architectural constraint is already seeing the benefit of making the system stateless. Because the system is not stateless, any number of layers can be introduced or the complexity can be distributed among multiple layers, such as caching layer, queuing layer, or even the data aggregating layer. A lot of the current day technologies like MapReduce, NoSQL databases, what you see, are a direct result of this layered architecture fashion. Because REST allows you to design your system to be layered, you can introduce a distributed NoSQL cache. You can also introduce a queuing engine so that the latency can be handled separately. You can even make a REST call asynchronous using this. Hence, layered architecture makes a big impression on your network architecture by reducing the complexity and making the system available all the time. Because a layer 1 fails, you can easily introduce a layer 2 or you can fall back on a second layer. It also allows you to incrementally improve the security within the system. Because of the uniform interfaces, now we can change the layers or we can improve the layers without affecting one another. All this benefiting the cloud applications very naturally and need of the hour by all the cloud service providers. In the last, we'll see code on demand, which is an optional constraint. A very good example of this could be that when a client requests the data from the server also sends a metadata. Along with the metadata, it also sends a script which can be executed on the client side. Such as when you connect to a web channel via the REST API, REST data returned to you will also contain some JavaScript code which can convert the weather data into a different units. Because often weather is seen as Fahrenheit or Celsius depending on the locality you are in, which can be easily converted using this script provided by the server itself. Thus, server has a consistency in the data which is being processed by the client as well. However, because this is an optional constraint, because of the security reason, if some browsers block such passing on JavaScript or blocking certain script, your application should be able to still work with making additional requests back to the server and should not break any of your application features. Because of this constraint, we can address and manage complexity to a large extent. We can even measure the perceived speed at the client side using this technology. A lot of, or even like Google Analytics, make use of such scripts executing on the client side to track the usage and the performance of their systems. With this, we move on to the summarizing what we discussed today. So we discussed today about REST, which is a network-based architectural style for distributed hypermedia systems. It offers 6 constraints, out of which one is optional, starting with client-server, stateless, cached, uniform interfaces, and layers, and optional constraint being code on demand. We also saw how REST solves some of the major network architectural problems which are inherent to the cloud services. We saw how REST can help in making your cloud services scalable, more elasticity, more reliable, and more easily manageable, almost without any human intervention. REST also enables interoperability in the ecosystem of hypermedia system. As a result, today you see many self-building applications. Simply provide the REST API endpoints, and there are many application websites which can build the application for you, such as the Internet of Things. Hence, we conclude today's discussion that RESTful characteristics are a natural fit for designing cloud services. Hence, any developer or an engineer who is looking to build a cloud service should definitely consider REST as one of the basic and fundamental necessity for building such cloud services. Thanks, and we now open for any suggestions, feedback, or for any questions if you may have.
Thanks for the insightful presentation, Basavaraj. Let's quickly take up the questions now. I request you to read out the questions and their answers so that all our users may listen to your insights. Are you able to see the question in your question doc, Basavaraj?
Yeah, I'm trying. Okay, I do see a couple of questions.
Taking them, Basavaraj?
Okay, I'm taking up one by one. I'm seeing a question from Uvashri Suresh. What is the proxy and how it would be act